Okay, can Okay, so now while I'm waiting for some of you to get ready, or at least try to get something out and put some, like get a paper out or foolscap paper out. I just want to say now actually you all know your potential lah, okay? So my hope for you all is that you all really know what is your potential, number one. But at the same time also is to put whatever that you have into action. So whatever that you do last year, for those who work hard, but for those who work hard, keep working hard this year. This year is going to be a lot more intense, especially when it comes to balancing all the academic needs for other subjects as well. That's number one. Number two, it is at the same time it is a bit mentally challenging also, because you are doing with new systems, you are dealing with new concepts. So you need to spend the time to think a bit. So homework really need to do, even though I won't chase as much as like what we do in lower secondary, right, or primary school, but you really need to spend the time to think through these problems. Okay, some problems are easy, so those to cover the basic concepts, but some problems are there for you to think a bit and then for you to get used to, because some of these thinking problems will come up in O-level and probably something in the future. Now, so the next question is, right, study so hard, like you study AMath and AMath, you study so hard, right? What's the point of this? There's 2 points. Now, the purpose of additional maths, right, is to gear you up for engineering math in the future. Okay, is to really gear you up for engineering math. Okay, to be very frank, most of the things you are learning, right, you won't see them in the future anymore. Okay, now I also don't know why. Yeah, I also don't know why. So mainly in engineering, but I think sometimes you can relate to human science, sometimes relate to economics. But the thing is, the scope is there, just engineering, economics, business a little bit. But like beyond that, how to run a business, you don't need circle property to know how to run a business, correct? You don't need to know logarithm to know how to run a business. Yeah. So the thing is that what we are training in AMath and AMath is to train in the logical thinking skills. Based on the tools that you have, how are you going to find your way out? Okay, so same thing in the future, based on the tools or the knowledge that you have, how are you going to solve your company's problem? How are you going to like build your own business and solve the problems there? Okay, so that is the main purpose of math, to get you engaged in thinking and the logical reasoning. Okay, so that's the biggest picture that I can paint for you, but otherwise the scope is just there. If you're very interested in engineering, then good for you, then you'll see a lot of things in your engineering course. Okay, alright, so with this, right, let's start 5.1. Which question do you feel more in need? Question 1, 2, 3? Which one? Anyone need question 1? Exit pass? Question 1? 2 don't need, 1 and 2 don't need. So 1 and 2, right, is mainly solving. So the strategy to solve in this question is convert to same base or convert to same power. Then you compare the other one. Okay, now then for question 3, express in the form. So it means we need to simplify a little bit. So how do we simplify question 3? Question 3 is ungodly. Aiyo. Okay, so for question 3, right, how do we simplify this? In order to combine everything into one, we need to make use of laws of indices, correct? And using the laws of indices means all the base must be the same, either same base or same power. Over here, the powers are all different. So what should we do? We look for the same base. Just nice, 7 and 49, they share the same base. So what we need to do is convert to same base first. So all the 7, I'm going to leave it there. Usually we convert to a smaller base. So here, 49, right, I can write this as 7 to the power of 2, and to use law of indices will be 2 minus 2x over here. Okay? Then this one 7, 2x plus 1. I'll leave this alone first, later you'll see a magic here. Now 49 to the power of x, so I can rewrite this as 7 square, and 7 square to the power of x is just 7 to the power of 2x. Okay, law of indices. Then the next one is 3, this one nothing to change. Okay, so more or less the top is more or less done. So if you can multiply the top, this will be just 7 to the power of 5x minus 2x minus 2, right? So this would be just 7 to the power of 3x plus 2 on top. Okay? Now at the bottom is where the curious thing happened. Because you want to simplify to one single term, okay? The problem is, right, this is 3 times 7 to the power 2x, 2 times 7 to the power 2x. This one is on its own, like there's the power a bit different. Okay? How do we make all this at the bottom to make it a like term? For example, how do I make it to the same variable kind of thing? Okay? So this one I can add together, correct? 3 of this plus 2 of this is 5 of this. Right? But this one how? Break the 7 out, correct? So this is 7 to the power 2x times 7. So get the 7 out now, okay? So this would be, okay, 7 to the power 2x plus 1 means I need to multiply by 7 to the power of 1. Okay? So this is the, yeah. Okay, so last, oh, haven't last yet. Okay, so we have 7 to the power of 3x plus 2 on top. At the bottom, right, okay, I have 7 of this, I have 2 of this, I have 3 of this. So 7 plus 2 plus 3, I have 12 of those things. So it means at the bottom it will be 12, 7 to the power of 2x. Okay, so far so good? Okay, now at the same time what I can do is I can combine this 7. So this would be 1 over 12 times 7 to the power of 3x plus 2. At the bottom we minus, correct? We divide, right? So when we divide, we minus off the power. So we need to minus 2x over here. So we have 1 over 12 times 7 to the power of x plus 2. So is this in the final form yet? The final form is in the form of a number times a number to the power of x. Over here we have a number, another number to the power of x plus 2. We don't need the plus 2. So it means that we can actually break out the plus 2 also. Okay, so what we can do is 1 over 12, and then we have 7 to the power of x times 7 to the power of 2. Okay? Then I can combine these two to be my constant a, and then this will be my 7 to the power of x. So this will be 49 over 12 times 7 to the power of x. Okay? So it is in this form. This is a, b to the power of x. Okay? A times b to the power of x. Okay, so it means that this is the one is how should I present my final answer. Okay? Okay, any questions for this? Can, a lot of us, very frequently we know how to combine, but in AMath we need to think a little bit of reverse. We need to know how to split them up. Okay, so the questions below you see how to split them up actually. Question 4, anyone need simultaneous equation? Anyone need simultaneous equation? Question 4, calling once, calling twice. Okay, don't need simultaneous don't need Okay, 5, I want to go through 5. Okay, so simultaneous equation, this one is important. Okay, so it will be indices, right, converted to simultaneous equation, and then you solve the pair of simultaneous equation. Okay, important skill to know. This one must know because, yeah, a possible thing to come out. Okay, now number 5 is also the next thing that I want to start. It's a special thing to solve where we transform the indices question into a quadratic equation, like your trigo like that. Okay, now that you see this, the trigo, you'll make a bit of sense when we review it. Okay, so let's take a look at 5a. For example, I have 19 times 2 to the power of x minus 2 minus 2 to the power of x is equals to 60. Okay, so we need to use a suitable substitution to make our life easier. Okay, so before we do the suitable substitution, we need to split all the powers involving the unknowns. So for example, this one is on its own, we can substitute this. Then this one is like that, so we need to split it out so that we can replace the 2 to the power x, we can replace this unknown. Okay, so means that I have to split this out, so this will be 19, then I will be 2x over 2 to the power of 2 will be 4. Okay, negative 2, so negative at the denominator. Okay, minus 2x is equals to 60. Okay, so here I'm going to use substitution. So which letter would you like other than x? Q? You want to use Q? Sure. Okay, so we let Q to be equals to 2 to the power of x. Okay, then, oh sorry, not let, we sub. Okay, we sub this into the equation. So we will have something like 19 over 4 Q. Do you see this? 19 over 4 Q minus another Q is equals to 60. So now this becomes a linear equation already. Okay? Yeah. So what is this? 19 over 4 minus 1. 15 over 4. So I have 15 over 4 Q is equals to 60 times 4 divided by 15. So this one will give you 16. Right? 16, So Q equals 16. Are we done yet? Solve already? Not yet. We still need to solve for x, the original one. So 2 to the power of x is 16. So x is equals to 2 to the power of 4. So x is equals to 4. Just like that. Okay, we can jump straight like that. Okay, unless you cannot see, okay, let me write out the full thing. So 2 to the power of x is equals to 2 to the power of 4. So x is equals to 4. Okay, like that. Okay, So this one, the substitution is a very important skill so that you can make your life easier. Now, same goes to the trigo one. Okay, you need to find something to substitute so that you can get a linear or a quadratic equation at the end. Okay. Okay. All right, let's look at B. Okay, let's look at B. Alright, so B, we have something like this. So a clue on when to use substitution, right? A clue is when your power has a 2x and an x somewhere in the power. Okay, so this will roughly tell you a clue that, okay, I'm going to need to prepare a quadratic equation. I need to sub somewhere. Okay, so how do I substitute this? Okay, so this one I can rewrite this as 3. Okay, because I need to replace 2 power x, so the square I can put on the outside. Okay, then this one over here, this will be 2 to the power x plus 1. So it means that 2 to the power x times 2 to the power of 1. Okay, then this will be minus 8 equals to 0. Then I can substitute the next thing. So sub, okay, u equals to 2 to the power x. Okay, so after I substitute, I will get this one. So 3 u square minus 2 u minus 8 equals to 0. You can do this. Okay. After this, what should we do? We can factorize, or you can do your quadratic formula. So this is 3u and u. I think 4 and 2. minus, okay, like this. Okay, so here u will be equals to negative 4 over 3, or u is going to be equals to 2. Okay, now after this, after we get the u, we need to find back the x. So we replace the u back with this, 2 to the power x equals to negative 4 over 3, 2 to the power x is equals to 2 to the power 1. Okay, so next question. Now, 2 to the power of something, will you get a negative number? Don't have, so don't have means there is no solution. Okay, so this one, no solution. You can put NA also, non-admissible. Okay, no solution. This one, 2 to the power x equals to 2 power 1, so x is equals to 1. And this is your final answer. So only one solution from this equation. Okay? Can, you may attempt to use your logarithm log base 2 of negative 4 over 3, but your calculator will tell you math error. Okay? Ln this over ln 2 also can. Yeah. Which one? As in, this one is x squared? No. It's like, right? 3 to the power a, the whole thing raised to the power b, so this is 3 power a times b. Yeah, so same thing, the 2 I bring it out, so it is 2 to the power 2x. Yeah. Okay, it's a multiplying thing over here. Okay? Law of indices. Okay, so this is B. Okay, C. There's another clue. Okay. C, there's another clue. Okay, now for C, right, how do you decide that you need a quadratic equation is that you see that there's a 3 over here, then there is a 9. Then when you convert to 3 square, this power become 2x plus 2, correct? So there's a 2x, there's an x at the power. So this is also telling you that you may need a quadratic equation. Okay, so this one convert to same base. So 3 to the power of 2x plus 2. Okay, equals to 1 minus 8 to the power of 3x. So this one, split it out, 3 to the power of 2x times 3 square. Okay, then after this, substitute with u or any other letter. So okay, this round I fun lah, let m equals to 3 to the power of 2x. Okay, so I have 9m equals to 1 minus 8m. Sorry, 9m square. Forgot to do one thing. So this one, 3 power x square. Sorry, forgot to do this. Okay, so I have a 9m square minus 1 equals to 1 minus 8m. Yep. Okay, then rearrange 9m square plus 8m minus 1. 9 and 1. Okay, so m is equals to 1 over 9 or m equals to negative 1. Okay, convert back to what we substitute. So 3 to the power of x is equals to, now if you want to rewrite this in the base 3, this is going to be 3 to the power of what? 1 over 9. So this 3 to the power of, is they have a square, correct? But 1 over means negative. So there's a negative 2 over here. Okay, 3 to the power negative 2. This one, 3 to the power of x is equals to negative 1. Okay, so first one over here, x is equals to negative 2. Okay, then the next one over here, any solution? No solution because positive number, negative number, so no solution. Okay? Huh? 3 part C. 3C. Sorry, 5C. Oh yeah, because I changed. I got say what I changed because I got say I changed, yeah? Got. I got which one? Yeah, correct. I got post, I got say change. Yeah. You go to your yeah, I asked you to change that question because that question got error. Yeah. Okay, so this is the one, this is the new one. Okay. Because someone do halfway and then stuck, then texted me. Yeah, that question got error. Okay, I knew it. Okay, alright, for part D. Okay, part D. We can, okay, so this one we can actually do something like this. So 2 to the power of 4 over 2 to the power of x. We can rewrite like this. Okay, so whenever you see a negative 4 minus x, don't worry also, you can split it out like this. And then you can continue to do your substitution. Okay, you can continue to do your substitution. So you have something like this. So u equals to 10 minus 2 to the power of 4 is 16 over u. Okay, multiply everything by u square, 10u minus 16. Rearrange. Okay, something like that. So at the end, I can convert back to the power of 8x is equals to 2 to the power of 3. So x is equals to 3. This one over here, 2 to the power of x is equals to 2 to the power of 1. So x is equals to 1. So this one got two solutions, 3 and 1. Okay? Okay, bonus. The bonus 2 questions. So far, any problem with the, only this one, right? Only C, right? The rest, okay. Can? Okay, 6. Okay, so 6 is a bonus question where you need to find that it is a multiple of 11. Okay, so when you show that something is an even number, let's look at a simpler example. Okay, so show that this one, let's say x and y are integers. So show that this is forever an even number. So how? What do you do to show it an even number? 4 times something is even, 6 times something is even, even plus even is even. That's one way to answer. The other way to answer is you need to factorize a 2. Correct? You need to get a 2 out. So 2 times whatever this is an even number. Okay? So we are going to approach this using this kind of thing. We need to get the 11 out. So in order to show that something is a multiple of 11, you need to show that it is 11 times something over here at the end of the day. You need to be able to factorize the 11 out. Okay? So this is the thing that we're aiming for. So let's try. So we start off with 2, 9 to the power of n plus 1, 3, 2n plus 3, minus 9 to the power of n. Okay, sure. Okay, so let's do a little bit of magic. What do we have? We have 9, we have 3, we have 9. So up to you. You want to convert to 3 or convert to 9? What do you think? Both also can, but which one you want? 3? Convert to 3? Okay, so let's convert this to 3. So I have 2. Okay, so 9, if I convert to 3, I need to square the thing, right? So when I square, the power times 2. Okay? Then over here, 2n plus 3. Okay, then this one, if I want to convert to a 3, this one will be a 3 to the power of 2n. Okay? I think you've seen enough from here to know this. Can? Okay, so how do we add everything together? Like the 7 just now. You remember the 7 question? The 49 and the 7? Okay, we are going to do something like that. So let's break everything down and leave this alone. Okay, so I'm going to have 2 times 3 to the power of 2n times 3 squared, so times 9. Okay, next one, 3 to the power of 2n times 3 cubed, so times 27. Okay, then this one I have a 3 to the power of 2n over here. Okay, so what I do next, add everything together because I have 18 apple over here, I have 27 apples over here, minus away 1 apple. So 18 plus 27 is 54, 45. 45 minus 1, I have 44 of them. Like that, 44 times 3 to the power of 2n. Then 44, I can write this as 11 times 4 times 3 to the power of 2n. Okay, because this is 11 times something, so the conclusion is this is a multiple of 11. Okay, because it is 11 times something. Okay? Can Now, the next common thing that I want to ask is caution. Okay, this one over here. 4 times 3 to the power of 2n. Okay, is this equals to 12 to the power of 2n? Can or not? 4 times 3 to the power of 2n is equals to 12 to the power of 2n. Can or cannot? Cannot. Why cannot? Because the base is different. Okay, the base is different. We cannot use the law of indices. And even so, the index also different. This is power 1. This is 2n. So the index are different. We cannot add together. Then this one, 4 to the power of 2n times 3 to the power of 2n. This one together, 12 to the power of 2n. Can. Okay, this one cannot. Okay, can. So the powers must be the same. Okay, powers must be the same for you to multiply them together. Okay, all right. B, show whatever that is can be divisible by 5. So means that we need to get a 5 out. Okay, B. Okay, so once we get this out, right, because we want to show that it's can be divided by 5, which also means that I need to show that it's a multiple of 5, correct? So what I can do is, same thing, same strategy, split everything out, get all the unknown indices together. So I have a 3 power x, 3 cubed is 27, okay, this one is 1 over 3 times 3x times 3 squared is 9 plus 3 to the power of x. Let me simplify this a bit. I have 27 of this. I have 3 of this. I have 1 of this. So 27 minus 3 plus 1. So this would be 20. Okay. Oh, it just ended just now, is it? Okay, nice. Okay, last one. Given that this, find 10. Okay. Okay. Question 7. Okay, now for the next question, the last bonus question, which is a bit tougher. Now, given an equation, they want you to find the value of 10 to the power of x. So the thing is, right, the problem is this. You cannot just divide 20 and 5 because base different, power different, right? You only can use your laws of indices if the base are the same or if the powers are the same. right? So what can you do to make the base the same? The way that you can do is you can split it out, okay? So before we split it out, right, let us do something over here. So over here, we split the powers out first so it's easier to see. So I have a 20 square over 20 to the power of x on the left. Okay. Over here I have 5x times 5 to the power 5 square. Correct? Laws of indices. I will split it out first. Let me group all my unknowns together and let me group all my constants together. So this 20 to the power x, I will bring it together so that the unknowns will be together. Okay? Then this one I bring it down. So I have a 20 square. 20 square is actually 400 divided by 25. So divided by 5 square, 25. Over here, right, I have, okay, maybe I shouldn't evaluate first. Maybe I should show you what's going on. Okay, something like this. So I move the 5 square down, the 20 power x, I multiply it over the other side. Okay, what is this? You can type out your calculator or you can 400 divided by 25. It's going to give you 16. Okay, this is going to give you 16. Yeah. Okay, this one over here, right? 20 power x, 5 power x. Because the powers are the same, we can multiply them together. So 20 times 5 is 100. So just nice 100 to the power of x. Okay? Next thing. Okay, the next thing. 100 to the power of x. How is it related to 10 to the power of x? 110. What's the thing? We need to, how do we get from 100 to 10? We need to 10 to the power of 2, or we need to square root, correct? Correct? So actually, technically speaking, 16 is here. 10 to the power of 2x, you can do this. If you want, or actually, yeah, I should do this. 10 to the power of 2x. Okay? So then when you square root, this will be 10 to the power of x. On the left hand side, when you square root, this will be 4. Okay? Now, the next thing is positive 4, negative 4. Which one is it? Yeah.
Root is nah.
This one is all. Okay, just paste here. Okay, enough. Okay, so how? Positive 4, negative 4. Which one do we reject? Positive can, cannot? Positive can? Can. So positive 4 is the answer. Negative 4? Cannot, because positive number to raise to any power is still positive. There's no negative number. So this one, reject. Okay? So like that. Okay? So the 5, 6, and 7 the main goal of 5, 6, and 7 is to show you the algebra tricks involving indices. Okay? Yeah. Alright, so 5.2, exit pass 5.2. Okay, question 2 and 3. Question 1, I will let you figure out, then I'll try to mark if possible. Question 2 is the one. Okay, I need to sketch this. And I need to sketch this. Okay? So do you remember how do we sketch exponential and logarithm graph? Do you remember how to sketch exponential and logarithmic graph? The answer is in your hands. This one, correct? So exponential go up, logarithm go up but another way. Okay? So exponential graph, this is the positive one. If the power is positive, then you follow this direction. If the power is negative, okay, now what I want you to think of is, even though the power is negative, there's nothing much to worry about, because y equals to 2 to the power of negative x. It simply means, if it's negative power, right, it simply means 1 over 2 to the power of x. Or it simply means y is equal to half to the power of x. So if x is 0, 1, y is equal to 1. If x is 1, half to the power 1 is 1, half to the power 2, 1 over 4, 1 over 16. So you start with 1, half, 1 over 4, 1 over 16, 1 over 32, right? So like that. Okay, so don't worry too much. Okay, so this is how the graph looks like this, towards the horizontal axis. This is 1. So this would be y equals to 2 to the power negative x. Okay? Next graph. This one, what kind of graph is this? Linear graph, right? So straight line, right? Go up or go down? Does it go upwards or does it come down? Come down, why? Negative gradient. Okay? Where is the y-intercept? Y-intercept is 5. Y equals to mx plus c. Okay? Y equals to mx plus c. So the c, y-intercept, is going to be 5. So your line will be like this. Okay? So this is y equals to 5 minus x. Okay? When you sketch, don't forget to label your axis. Don't need to do 1, 2, 3, 4, 5, just sketch. Okay? Now, the next question is state the number of solutions. So if we are looking for number of solutions, means we are looking for number of intersections, correct? So how many intersections you see? 1. So this is only one real solution. Okay, just like that. Just one real solution. Okay, why? The reason. Okay, question? Yeah. 2? Oh, it won't actually. That side will go like. Let's try and see. Try and see, Oh yeah, got 2 leh. Sorry, got 2 intersection. Okay, sorry. Okay, so my graph a bit problematic. So sorry, got 2 intersection because, yeah, the other side raises exponentially, so it actually rises quite fast. So it's actually something like this. Yeah. Shouldn't be curved lah, but. Okay, my bad, sorry. Let me do something like this. Woo! Okay. Let me just exaggerate a bit. Okay. Ayah. Okay, so yes, 2 points of intersection. Thank you. Anson, thank you for showing. 2 points of intersection. Yeah, got 2. Because the other side rises quite fast. Got 2. Because this side rises quite fast, so must have 2. Okay? Which one is not supposed to be curved? This one? Sorry lah, my blackboard, whiteboard. Use ruler, okay? You use ruler. Okay, question 3. Okay, question 3. Now, we have a curve over here. So this is y equals to a times x power b plus 5. Okay, so when you see this, right, you may be a bit confused. But I want you to differentiate a bit. Even with unknowns, there are 2 different kind of meanings. Okay, so for x and y, these are your variable. Okay, x and y, these things are your variable. So what is actually variable? Variable is actually a slot that you can put in any number. Okay, x and y can be any number. But this one, a and b, these 2 unknowns, they are called constants. Okay, so there is you need to differentiate between a variable and a constant. So constant means that there is already a fixed number for A and B. Okay, so what you need to do is you need to find and solve for the fixed number A and B. Okay, the X and Y are the variable. Okay, so in this case, based on this equation, okay, at the first point, at 314, okay, at 314, X is 3, Y is 14. So I just replace this into this equation. So this will be 14 equals to A times 3 to the power of B plus 5. Okay, so let me rewrite this a bit. So this is 9 is equals to A times 3 to the power of B. Okay, so this is the first one. Okay, then at the second point, pass through the second point, right? Means if they pass through the second point, I can sub it into the equation. So this is 9 is equals to A 2B plus 5. Okay, rearrange a bit. So 4 is equals to A to the power of 2B. So equation 1, equation 2. Now for exponential functions, for exponential unknowns, how do we do elimination or how do we do substitution? Instead of adding and minusing, we do times and divide. So what we can do is I can take 1 divide by 2. Okay, so 1 I divide by 2. So on the left hand side, 9 divided by 4. So this is 9 over 4. Right hand side, this thing over this thing. So A times 3 power B over A times 2 power B. So over here, we can already eliminate the A. Okay, we can already eliminate the A. So 9 over 4 is equals to 3 over 2 to the power of B. Okay, so what is the power of B? 3 to the power of what is 9? 2 to the power of what is 4? 2, power 2. So this one I can write this as 3 over 2 square, 3 over 2B. So the last one is B is equals to 2. Okay. Need space for A. Okay, can. Okay, so how to find A? I can use either equation 1 or equation 2. So I use equation 1. 9 equals to A times 3 square. Okay, so 9 is equals to 9A. So A is equals to 1. So B equals to 2, A equals to 1. Indices, short, a lot of things to, like, even though it's a short 5.1, right, there's a lot of things to learn. So, and a lot of variation that you may see. So this one you be careful, okay, revise well, but it won't go, as in like you just try to get the basic idea correct. That should be okay, okay? Okay, so tomorrow, logarithm. Are you still